let's remember something cool about inverses. And that is, again, assuming that f and g are inverses, right? Let f and g be inverses. Then if I put one function inside of another function, if I do a composition of an inverse and its function, whatever you put in, you'll get out. If you go back to my little function machine, right? Machines, when you had Fahrenheit to Celsius, and then Celsius to Fahrenheit. If I put in 32, I get out a 0 Celsius. If I put in a 0 Celsius, I get out a 32. So if I put one function inside of the other, in other words, if I put in a 32 here, g of 32 would give me 0 degrees Celsius. F of 0 degrees Celsius would give me a 32 again, right? So that always works. If you put in an x and you do a composition of a function and its inverse, you get out an x. You can stop and think about that if you like. But let's see what this does for us for our derivatives. Can I take the derivative of this? Sure, the derivative of composition.
Sure.
Chain rule, the derivative of the outside times the derivative of the inside. So the derivative of the outside is f prime, g of x, times the derivative of the inside. Wow, that's not bad. Derivative of x? 1. So let's see. I want to find g prime of x, so let's get g prime of x by itself. I'm going to divide. Do you still have me?
Yep.
All right, so that's going to be 1 divided by f prime of g of x. And that is something that would be true for all derivatives of inverses. The derivative of inverse at a point or at an x is going to be 1 over the derivative of the original function at g of x. Pretty cool. Should we try the one we just did?
Sure.
So let's look at this problem which we just did kind of the basic way, which was finding g of x, the inverse of f of x, and then taking the derivative. We did that using implicit differentiation, if you remember. And then finding the exact value. We want to find the value of g prime of negative 2. But let's see if we can use this handy thing, shall we? All right, so this says to find g prime of negative 2, it's going to equal, I guess I'll put in my negative 2 right away. 1 over f prime of g of negative 2. All right, well, let's see how this works. So f prime, let's find the derivative of f. F prime of x is going to be 12x squared minus 2. All right, so g prime of negative 2 is going to be 12. Now, instead of x, of course, I'm going to put g of negative 2 squared minus 2. All right, that doesn't look too bad. But there is the tricky bit, finding g of negative 2. G of negative 2 is basically the y value of g when x is negative 2. I'm going to make a little chart over here. So when x is negative 2, I want to find what the y value is, what g of negative 2 is. But I don't have the function g to work with. I just have the function f. Well, let's take my f of x here, and let's think about that. Because, whoopsie-daisy, since g and f are inverses of each other, when the x is negative 2, that's going to be the y here. So whenever x produces a y value of negative 2 in my f function, will be the y value of my g function. You see how that works? That is tricky. All right, so let's go back to my original function here. So I basically want to say when f of x is -2, what is x equal to? And we did this in the last problem. You can solve this. It's tricky to solve it algebraically. You can solve it graphically using your graphing calculator. Y equals -2. Y2 equals 4x cubed minus 2x, and see where they intersect. Or you can think about it. What x value would make this true? And I think we decided that -1, 4 times -1 cubed is -4, plus 2 is -2. All right? But if that just freaked you out, you can use your graphing calculator and just see where those are equal. Okay? So what that gave me is this information. When x is -1, f of x is -2. Since f and g are inverses, that means when x is -2, its y is -1. So g of -2 is going to be -1. So I have 12 times -1 squared minus 2. That gives me 12 times -1 squared, 1/10, which was the answer that we got when we did it the other way. Okay? Again, I strongly, strongly recommend you just make this little chart here. X, f of x, x, g of x. It makes a big difference. All right?